Gaia BH1, the black hole hiding in our cosmic backyard. What if I told you that there's a black hole hiding right in our cosmic backyard, one that remained invisible to our eyes for a long time? It's true. Gaia BH1, the closest black hole ever discovered to Earth, was quietly lurking there without drawing attention until scientists uncovered some surprising clues to its presence. But how did it stay hidden for so long? Could there be others this close to us? And most importantly, does it pose any threat to us? Rest assured, the answer may surprise you. Before revealing the details, you need to understand how astronomers managed to unveil this invisible giant and what it can teach us about the universe. Stick around until the end, because we'll explain how black holes may be much closer than we imagine, what happens if someone gets too close, and why this discovery has forever changed our perspective on the cosmos. What is Gaia BH1 and why is it so special? Imagine having a neighbor who has lived right next door for years, but you've only just realized they were there. Gaia BH1 is a black hole discovered relatively close to Earth, about 1,600 light-years away. That may sound far, but in cosmic terms, it's practically in our backyard. To put it into perspective, light, the fastest thing in the universe, takes 1,600 years to reach it. What makes this black hole so special is that it's the closest to Earth ever found. Previously known black holes were located much farther away, in regions almost unreachable for our telescopes to study in detail. Finding one so near helps us better understand our cosmic neighborhood and suggests that these mysterious objects may be more common than we thought. But Gaia BH1 isn't floating alone in space. It's part of a binary system, meaning it's accompanied by a star similar to our Sun. They orbit each other in a kind of gravitational dance. This discovery is incredible because it shows that black holes can hide even in stellar systems that appear perfectly ordinary at first glance. It's like discovering a treasure buried in your backyard, revealing that space still holds countless secrets waiting to be uncovered. How did scientists discover Gaia BH1? Scientists discovered Gaia BH1 by analyzing data from the Gaia Space Telescope, a European Space Agency (ESA) mission designed to map billions of stars in the Milky Way with extraordinary precision. Gaia monitors the motion of stars over time, helping us understand how they move and interact in space. During these observations, astronomers noticed a particular star moving in a strange way, as if something invisible was exerting a gravitational pull on it. This star wasn't following a normal trajectory. Instead, it seemed to wobble or oscillate, suggesting the presence of a massive, unseen object nearby. Initially, scientists thought it might be another star, but precise calculations showed that there was no visible light emitted from the supposed companion. That's when they realized the only explanation was a silent black hole, one that emitted no detectable radiation. Because black holes can't be observed directly, scientists used a method called astrometry, which involves studying the motions of stars to infer the existence of unseen objects. It's similar to watching a leaf floating on a lake and deducing that something large and heavy must be lurking beneath, even though you can't see it directly. To confirm their findings, astronomers used ground-based telescopes to measure the mass of the hidden object. Using advanced technology and precise calculations, the mysterious Gaia BH1 was finally unveiled. Why is it hidden? When we think of black holes, we often picture them as cosmic monsters devouring everything around them and shining intensely. But not all black holes behave this way. Gaia BH1 is an example of a silent or dormant black hole, meaning it's not actively pulling in large amounts of matter. Black holes only emit radiation and shine brightly when they're consuming vast amounts of gas, dust, or nearby stars, causing immense energy explosions. However, Gaia BH1 is quiet, hardly interacting with its surroundings, making it invisible to telescopes that detect visible light, X-rays, or infrared radiation. This is because Gaia BH1 lacks an accretion disk, a ring of matter spinning around it and releasing energy. Instead, it reveals itself only through the gravitational pull it exerts on its companion star, causing unusual oscillations. It's like a silent thief that leaves no obvious clues, but still influences everything nearby. What's fascinating is that black holes like Gaia BH1 may be far more common than we imagined, hiding in systems that seem ordinary. This discovery suggests that the universe could be teeming with these invisible giants, waiting to be found with new technologies and advanced methods. How big is it? Gaia BH1 has a mass about 10 times greater than our Sun's, meaning it exerts a tremendous gravitational pull on everything around it. For perspective, an object this massive would normally occupy a huge volume, but a black hole compresses all that matter into an incredibly tiny space. If we were to measure the physical size of Gaia BH1, its diameter would be only a few kilometers, comparable to the size of a small city. This is because the black hole's gravity is so intense that it crushes all the matter inward into an extremely dense point called a singularity, where the usual laws of physics break down. Surrounding the singularity is the event horizon, an invisible boundary beyond which nothing, not even light, can escape. Although it is small in size, its influence is enormous, capable of distorting space-time around it, as if creating an invisible whirlpool in the cosmos. Compared to the supermassive black holes found at the center of galaxies, Gaia BH1 may seem modest, but within our cosmic neighborhood, it is a true giant. Discoveries like this show us that stellar black holes may be much more common and discreet than we imagined, hidden among ordinary stars and waiting to be detected. Does it pose any danger to Earth? Rest assured, Gaia BH1 poses no danger to Earth. Although 1,600 light-years may seem like a short distance in cosmic terms, in reality, it is an immense distance. To put it in perspective, light, which travels at about 300,000 kilometers per second, takes only 1 second to travel from the Moon to Earth and about 8 minutes to travel from the Sun to us. Now, imagine light taking 1,600 years to reach Gaia BH1. This shows how far it really is. Even if we had a spacecraft traveling at the highest speed ever achieved by humans, it would take millions of years to get there. Moreover, Gaia BH1 is neither approaching Earth nor swallowing everything around it. It simply orbits its companion star peacefully, without any signs of destructive behavior. Unlike what we see in movies, black holes are not cosmic vacuum cleaners, indiscriminately sucking up everything. They only exert an attraction on objects that come too close, within the so-called event horizon, which in the case of Gaia BH1 is relatively small. Since it is stable and not interacting with large amounts of matter, we can safely study it and use it to better understand these mysterious objects in the universe without any risk to us. What does its discovery teach us about the universe? The discovery of Gaia BH1 teaches us that black holes may be much closer to us than we imagined, hidden in seemingly ordinary star systems without visible signs of their presence. This reveals that the universe still holds many secrets, and that there may be many other silent black holes scattered throughout our galaxy, waiting to be detected. This finding makes us rethink the strategies for searching for these enigmatic objects, showing that we cannot rely solely on observing intense radiation, such as X-rays, but also on methods that analyze the movement of surrounding stars. Furthermore, Gaia BH1 helps us understand how very massive stars die and collapse into black holes, providing clues about the stellar life cycle. Since it is in a binary system with a sun-like star, its observation allows us to study the dynamics between a black hole and an ordinary star, which is essential for better understanding the evolution of binary systems in the cosmos. This information can even help us predict the future of our own solar system if an extreme cosmic event occurs. The discovery also makes us reflect on the possibility of dormant black holes scattered throughout the galaxy, orbiting stars without drawing attention, and how these objects may influence the structure of the Milky Way over time. What happens if someone approaches a black hole like Gaia BH1? If someone were to hypothetically get too close to a black hole like Gaia BH1, they would face an unpleasant and quite strange fate. The extreme gravity of a black hole acts so intensely and unevenly that it would cause an effect known as spaghettification, where the person's body, or a spacecraft, would be stretched absurdly. This happens because the gravitational force on their feet, for example, would be much stronger than on their head, stretching them like a giant spaghetti noodle until they are completely disintegrated before reaching the center. This force increases as one approaches the event horizon, which is the boundary from which nothing can escape, not even light. Inside this region, space-time is so curved that all directions lead inward, and any object crossing this limit is lost forever. However, if someone remained at a safe distance, they could orbit the black hole without problems, just as planets orbit stars. Studying such phenomena is crucial for understanding extreme physics and the limits of human knowledge about the laws of the universe. Black holes like Gaia BH1 challenge us to explore concepts such as quantum gravity and the nature of space-time, revealing secrets about how the cosmos truly works.